for given solvent. If I have a lot of stuff dissolved in a bit of a liquid or a solvent, then that's concentrated. And dilute is low solute for a given amount of solvent. So in a solution, I'll have only a little bit of this in a solution. There's a picture in your PowerPoint that sort of visually tells you how these things work. Now, the next concept you need to understand is pH. What is pH? Now, we said that an acid is a proton donor, right? An acid is a proton donor. If I put it in water, what will it do? It will make H positive ions. That's what an acid is defined to be. So obviously it makes sense to measure the strength of an acid in terms of how much H positive it produces. And that's effectively what pH is. pH is a logarithmic scale that we actually use to measure the strength of an acid. Alright, so we measure the concentration of H positive, and the way it works is this. pH equals minus log to the base 10 of H positive. This bracket means concentration. So it just means pH measures the concentration of H positive ions. That's all it is. And the reason why it does that is because, as I said, we've defined an acid to be something that gives H positive ions. So obviously the more H positive ions it gives, the more acidic that substance is, and the lower the pH will be. Now, if I take three acids, right, I'll take HCl, H2SO4, and ethanoic acid, which was CH3, COOH, and I have 0.1 moles of each of them. And I ask you to find the pH. Actually, I won't do 0.1, I'll just do 1 mole. Alright? So there's 1 mole per liter is the concentration of each of these three acids. And I ask you to find the pH. All the three acids have the same concentration. Does that mean they will have the same pH? No. Because pH is not a measure of concentration of the acid, it's a measure of concentration of the hydrogen that is produced by the acid. This is a strong acid, so it will completely break down. So for each HCl, there will be 1 H positive. This is a strong acid as well, but this is diprotic. So for each H2SO4, I'll get 2 hydrogens. This one will give me 2 H positive. This is a weak acid, so not all of it will break down. So, because I don't tell you, let's just say, it ionizes 50%. So for each, I'll only get half a H positive. Alright? So to calculate the values of these things, for this guy at the pH, I just put 1 in there. And I will, so the pH of this guy, I can just put 1. For this guy, I'll actually have to double the amount. So I'll have to, double, so put 2. And for this guy, I'll actually have to put half. And then these things will actually give me the pH. So we can see that even though they all have the same concentrations, they have different pHs because the amount of hydrogen produced by these three acids is different. Monoprotic strong acid, diprotic strong acid, weak acid. Alright? Now moving on, the next thing we're going to have a look at is an acid conjugate base and an acid conjugate base pair. Now what that means is this. Again, as I said, an acid is going to ionize in water, right? And when it ionizes in water, it donates a proton. When it donates a proton, when it goes on the other side, it actually becomes a conjugate base. So let's have a look at an example. HCO3 negative plus H2O. And I put this in water, and what I actually get is this. Alright? And what I can do for that is, and I also should get, this guy's just taking the hydrogen, so I should get OH negative. So that's one of the things that I can actually have. Or it might be better, alright, yeah. And then the other thing that I can actually do is this, HCO3 negative plus H2O will make CO2 negative.